Hello students, welcome back to my channel Infinity Minds where maths is made easy. Today we shall be doing chapter number 4 Quadrilaterals of Ganita Prakash-I. Page 94, figure it out, question number 1. So without much delay, let us begin. Question 1 of page 94 says, find all the other angles inside the following rectangles. So you are given a rectangle ABCD in which you have only been given the value of this angle, children. Okay. First of all, you should be knowing as to what is being asked. You are being asked to find all other angles. Other angles means what? See, of course, there are four corner angles in a rectangle, angle A, B, C and D. They stand at 90 degrees, that everyone anyways knows. That is not being asked. The diagonal AC and BD, the two diagonals of the rectangle, are dividing the angles into further sub-angles. Okay, so they are the ones that have been marked. These angles I have marked. The textbook just gives this one angle to be 30 degrees and you are to find all other angles. So first of all, let us mark as to which all angles are we required to find. Say we mark this as angle 1. Angle 1 is given to be 30 degrees. That is already given. That is a given fact. And you have to find all other angles. That is, you have to find angle number 2, angle number 3 up till angle number 12 as marked or shown in the diagram. Next to 1, adjacent to 1, let us mark angle 2, then angle 3, angle 4, going clockwise, angle 5, angle 6, then angle 7 and angle 8. Each angle has been divided into two parts, but they aren't necessarily equal. Okay, the diagonals don't bisect the angles in a rectangle. That property is true for some other quadrilateral that we will see, okay, as the question will approach. And say the point of intersection is M, and around that point also, if you notice, four angles are getting formed. Say we call them 9, 10, 11, 12. See, giving them number values slightly, makes your task little simpler in naming of angles. Otherwise, one would name, we have angle 1 equals to 30 degrees. We would have to name this as angle MAB. There is absolutely no problems in this. Just that naming it in three alphabets makes your task much more complicated and tiring when naming. You would name this as MAD, MAB, ADM, MDC. So yes, it is much simpler. Practically, this is really comfortable way to name them with angles, numbers. Okay. Now, as we all know that each angle of a rectangle is a 90 degree. So, this entire angle A is 90 degrees. That we already know. But A has been broken up as sum of parts of two angles. Angle 1 plus 2 shall give up to angle A. That is 90 degrees. So, 1 plus 2 together will add up to 90 degrees. Of which, if the value of 1 is given to be 30, so the 2 can be solved as 60 degrees, right? So angle 2 will come as 60 degrees. So now moving further, if we notice, so there is a property in rectangles. The diagonals of a rectangle bisect each other. Diagonals of a rectangle bisect each other. If not given, you are expected to write down that property. But as of in this, the putting of these cut lines in the diagram talks about the equality of these parts. See, MA equals to MD, in a way it is given in your question. So fine, absolutely no problems. But you should be aware that just in case supposedly it's not given, then also diagonals bisect, that property needs to be written and made use of. Then the question becomes slightly more indirect for you. Okay, there you are expected to write the reason there. Anyhow, coming back to this where it is already marked, since the cut lines are marked, we know that MA equals to MD. Let me erase the other part so that it is more clear to you. Now, getting into this triangle MAMD, getting into this triangle AMD, if we have two sides to be equal, angles opposite equal sides are equal. That is, angle 3 is expected to be equal to angle 2, but obvious equal to 60 degrees in this case. Okay. And this you've studied in class 7, or there can be another name for it as base angles. Angles opposite equal sides are equal. Either of them is, that's the way to call it. If you have two sides in a triangle to be equal, then angles opposite equal sides are equal. Okay. Now once angle 3 is done, see it's going to be little similar what the approach that we've adopted. Value of angle 1 is given, so 2 can be found because the total it's a right angle. From 2 to 3 it is base angles. Angles opposite equal sides. Once 3 is solved, 3 to 4 again, yes, right angle. So 4 can be solved. So 3 will be 9. 3 will be your again 60 degrees. And then coming to 4 becomes 30 degrees. Back to 30 degrees. So after angle 4, now very similar stuff we are going to apply again and again. Coming to this triangle, CMD again base angle. So 4 equals to 5 base angles. And then 5 plus 6 right angle. Then 6 and 7 base angle. 7 and 8 right angle. So on. So this is as far as the corner angles have all been solved. That is value 1 to 8 is solved using base angles and the total being a right angle. Now how about this? Coming to one of the triangles, if two angles of the triangle is solved, we can get the value of the third triangle. In triangle AMB, if one is 30 degrees and the other has also been found to be 30 degrees, so that in a triangle, sum of three angles of a triangle measures 180 degrees. Angle sum property. Applying that rule, we can add up 30 and 30, 60, 180. So the value of angle 9 also comes to be 120 degrees. Once angle 9 is solved, 11 can be called equal to 9 as vertically opposite. When two lines intersect, the pairs of vertically opposite angles are equal. Class 7. Right? 9 plus 10 can be a linear pair. Together they are forming a straight line. So that is also done. And from once 10 is done, so 12 can of course be found either as vertically opposite or linear pair to 9. Okay, linear pair to 9 or 11 or vertically to opposite to 10, either of them. So in the end, you could write the measure of all of these. Clear, students? So this is as far as your solving is concerned. I have shared the answer slide with you and explained you also. Now coming to the fact solving, this is one of the ways of solving. Okay, this is one of the ways of solving and not the only way to solve. For example, in this same question, we can say opposite sides in a rectangle are of course parallel and AC can act as a transversal. So angle 1 can be called equal to angle 5. For example, one of another way, what are these angles? In that case, it's a combination of alternate interior angles. Okay. I don't want to confuse you. It is absolutely fine. The solution I've shared on the board is most friendly for students. Generally, children find this slightly more challenging. What I've shared is there, not a problem. But just for your knowledge shouldn't remain incomplete. After all, coming to Infinity Minds, you should be aware of all the various ways of solving as well. Like this is alternate interior. Then another one could be like when BD would act as a transversal, then again alternate interior, then next to 90 degrees and so on. There can be various possible combinations. All are acceptable as far as they remain correct. So be clear, practice and get your method clear in your minds. Okay. There's another one, second part to practice. First, you must pause the video and try it out entirely by yourself. It is absolutely the same. Slight one difference you could observe in it. Okay. Like it is the same rectangle with same pair of angles getting formed. What is different is what is given to you. Angle at the in the middle, at the point of intersection of the diagonals is given, and you have to find all other. In a way, their logic would remain same, that they 1 plus 2 will together form a right angle. 2 and 3 are going to be base angles, and we can move on in the same manner. But first, one of the values for them needs to be solved. What is given is around this point. Once this is given, you can solve all angles around the point of intersection M. I hope that is not a problem. Like 9 and 11 are going to be vertically opposite. Then 9 and 10 can come with linear pair. Okay. 9 and 11 vertically opposite. 9 and 10 linear pair. Then 10 and 12 again vertically opposite. So points around this shouldn't be a problem. But now how to move from this to the outside? Even if one of them we solve, we know that we can move over to the other points. Let us see. Again, it is the cut lines are already made, diagonals bisect in a rectangle. So we do have, angle 1 equals to angle 8. Same base angles. Angles opposite equal sides are equal. That we know. 1 is equal to 8. Now in the triangle, angle sum property holds after all. Okay, angle sum property holds. Sum of three angles total is 180 degrees. Now of which angle 11's value is with us 110. That means there is only 70 degrees left to be occupied by 1 and 8. If this is 110, this is a triangle and one of the angles is 110. So out of 180 degrees, only 70 degrees now left to be spread over to these two. Fine. But in such a way that they both are equal. So, but obvious, each is going to be 35. Got it? So, only a way of presentation is what needs to be seen. 1 plus 11 plus 8 is 180 degrees. Now, as we know, 1 and 8 are same. So, let us replace 8 by 1 because 8 is equal to 1. You require to change one of them in terms of the other. So 1 plus 1 means twice angle 1. 110 will go there and transpose minus, that is 70 degrees. Twice angle 1 is 70 degrees. So angle 1 is 35. We are getting my point. For example, just in case, some children can also prefer doing it with x, like if its value is x. So the other one's value is also going to be x. It's like, because they are same, that we need to have, because both values are same. X plus 110, like a typical linear equation they solving for x. Yes, that is also possible. That's the similar way we are doing. You need to replace one of them, as you cannot solve for two unknowns and they are actually same. So it's simple that 110 goes, so 70 is divided into two equal parts, but you should know how to write your answer also. Now once this is done, we know. After this we can proceed like we did it in the last one also. Rest I leave it up to you now. Mainly if your value of 1 is done, instead of if this is a 35 degree, so 90 minus 35 will give me angle 2's value, because total is going to be 90 degrees. So that makes it 55. Once angle 2, 2 and 3, base angles, 3 plus 4, 90 degrees. Then 4 and 5 base angles. Then 5 and 6, 90 degrees. Then 6 and 7 base angles, and so on. Okay. I hope the method was absolutely clear. They both are very, very similar with very minute difference. Okay. Do practice. Go through the video once again if need be, but practice it. Okay, thank you everyone. Do like and subscribe to my channel. Keep watching for more informative videos. Thank you.